Hello everyone. Today we gonna start the magnetic field produced by current through a circular loop of a conducting wire. Okay. So here we will use the right hand thumb rule in order to understand the magnetic field produced by current carrying conductor, which is shaped in circular loop form. So here we have the circular loop like this. Okay. Here we have connected that circular loop with external source of electricity. Okay, here we have resistance so that we can adjust the flow of current. Here we have ammeter, as you can see in that diagram, and here we have the battery, which is the external source of electricity, and we have connected that with the circular loop here. Okay, let me draw a little bigger circular loop like this. Okay, so that vertical line, which is the long, represent the positive terminal of the battery, and that small vertical line represent negative terminal of the battery. Is it? And here we have given key in order to switch on or switch off the flow of current in the circuit. So the direction of flow of current will be from positive to negative. That means in this side like this. Is it, everyone? Yeah, like this. Okay.
Yes, sir.
So according to the right hand thumb rule, when current is flowing in upward direction, okay, like this, vertically upward direction, then magnetic field produced will be in anticlockwise. Is it? Will be in
Yes.
anticlockwise. Yes. So for this particular point, let this point be P. Suppose this point is P. Okay. So for point P, current is flowing in upward direction. Is it? So if current is flowing in upward direction, then the direction of magnetic field will be like this. Is it or not?
Yes.
Yes. And from here like this. Okay. And for point, see, it is for point P, and I am here drawing the point Q. Okay. So just think opposite. If the current is flowing in upward direction, okay, upward direction, then the magnetic field produced by that wire will be in anti-clockwise direction. Is it?
Yes.
Okay. Now just think opposite. When current is flowing in downward direction, okay, then the direction of magnetic field will be clockwise direction. Is it or not?
Yes.
Yes.
Yes, sir.
So for point Q, the direction of magnetic field will be in clockwise direction like this. Is it, everyone?
Yes.
Yes. So just think that particular part here. Let me draw with the black ink so that you will identify it separately. Just think about that particular part over here. Okay, that part. It is visible, everyone? I am just highlighting that with blue or black coloring here.
Yes, sir. Yes.
Yes, it's visible.
So here,
Yes.
can we draw the magnetic force of line like this? If we will get bigger and bigger, the larger vertical line or that magnetic force of line, so in that particular region, that like magnetic force of line will be vertical. Is it? Just do reply.
Yes.
Because
Yeah.
magnetic force of line, they are emerging from that part and ending over here like this. They are emerging from here and they are ending in this particular region. Is it or not?
Yes.
Yes. Now we are going to understand about the magnetic field produced by the bar magnet. So suppose this is the bar magnet I am drawing here. This is the bar magnet. You know what is bar magnet? The magnet which represents like this, and here we have north
Yeah,
and
vertical
south.
magnet.
Yes, and here we have north and south pole. So magnetic, if we will draw the magnetic force of line, okay, for that particular bar magnet, here we have bar magnet. So we know that the magnetic force of line, they are producing or emerging from the north pole and ending on the south pole, like this. Is it? And this magnetic force of line never intersect each other. Is it or not?
Yes.
Yes. And if we will draw that magnetic force of line inside the magnet, then we will find like this from south to north, like this. Is it? Outside it is from north to south. Okay. Outside it is from north to south, but inside the magnet it is south to north. Is it? Keep replying. Samarth?
Yes, sir.
Yes.
Yeah.
Yes. So if we will compare magnetic field produced by the circular loop and the bar magnet, what similarities you will find here? So the magnetic field produced by the circular loop, it is as similar as magnetic field produced by the bar magnet. It is a circular loop. Circular loop. Okay, and here we have the bar magnet. So here we can conclude that the magnetic force of circular loop, or magnetic force produced by circular loop, is as similar as the magnetic field produced by the bar magnet. Okay, so see here, when the magnetic force of line emerging from that particular region, so we have to represent that with the north pole. It is as similar as the north pole of the bar magnet, and that particular region here, magnetic force of line are ending here. Okay, then it is the south pole. Hence we can conclude that the magnetic field produced by the circular loop, okay, when current is passing through the circular loop, then the magnetic field produced will be similar to the magnetic field produced by the bar magnet. That means that circular loop is acting as a permanent bar magnet. Permanent bar magnet. Okay, is it everyone?
Yes, sir.
Yes.
Yes.
So just to remember, yes.
How can we say circular loop is a permanent bar magnet?
Okay, see, suppose here we have only one circular loop. Okay, if we will have n number of circular loop like this, n number of circular loop like this. Okay, and then we have to connect that device, that circular loop, with that particular arrangement. So here, see, magnetic force of line for all the circular loop will be emerging, the magnetic force of line will emerging from here, and that will ending over here, when the magnetic force of the direction of current will be in this direction. Okay, so you will find that magnetic force of line will be as similar as the magnetic field produced by the permanent bar magnet. That's why we can say that magnetic field produced by the circular loop is acting as a permanent bar magnet, because their magnetic field is similar. Understood, beta?
Yes.
Yes, sir.
Okay. So the magnetic field produced by the circular loop is as similar as magnetic field produced by the bar magnet. That's why we can say that magnetic field produced by the circular loop, okay, which is as similar as the magnetic field of the bar magnet. Hence, circular loop is acting as a permanent bar magnet. That's all about the activity. So I want everyone had to take a screenshot for that. It is very important.
Done, sir.
Everyone done?
Done, sir.
Okay. Any doubt here?
What else?
Okay. Now we will understand the magnetic field due to current flowing in a solenoid. So first we have to understand what is solenoid. So solenoid is nothing but n number of insulated copper wire wound in the form of coil. Okay, in the form of coil is called as solenoid. So I'm writing definition over here. Okay, so the definition of solenoid. Wait a second, someone is in waiting room. Kritika. Okay. So I'm writing here the definition of solenoid. Solenoid. Okay, solenoid. Any idea about solenoid? Okay, I'm just going to write here. When n number of or many turns of insulated copper wire. Insulated copper wire, sometimes aluminum also. Copper or aluminum wire wound in the form of coil is called as, it is WOUND, wound in the form of coil is called as solenoid. Understood everyone what is solenoid? When many turns of insulated copper or aluminum wire wound in the form of coil. Coil means many, like chain of loops. Okay, that coil means what? Chain of loops. Okay everyone. So when many turns of insulated copper wire or aluminum wire wound in the form of chain of loop, or you can say coil, is called as beta solenoid. It's called as solenoid. Understood everyone?
Yes.
Yes. So whenever an electric current passes through solenoid, magnetic line of force are produced in pattern as shown in the figure. We already understood in the previous activity. There we have understood only for one loop. Okay. So here we have many loops, as you can see here, 1, 2, 3, 4, 5, n number of loops we have here. You are aware that the magnetic line of force of the bar magnet. Okay. So here also we can conclude that the magnetic force of line produced by solenoid is as similar as magnetic field produced by the permanent bar magnet. Okay. So the property of magnetic field of solenoid are very similar to the magnetic field produced by the bar magnet. Is it? Hence, that solenoid is, when current is passing through that solenoid, that time it is acting as a permanent bar magnet. One of the open end of the solenoid act as a north pole and other end will act as a south pole. The magnetic line of force inside the solenoid are parallel to each other as similar to the magnetic force of line inside the permanent bar magnet. Okay, suppose we have here the permanent bar magnet, here we have south pole and here we have north pole. So that magnetic force of line will be as similar to the magnetic field produced by that particular bar magnet. Okay, what does this mean? It means that the intensity of the magnetic field within the solenoid is uniform everywhere. That is, the magnetic field in a solenoid is uniform. It shows that it is as similar as the permanent bar magnet. Okay everyone? Understood everyone? Keep replying.